Hi everyone, good morning.
Hey Sachin.
This is your host Sachin Kelkar. I look after the developer program for Asia Pacific for Intel, and welcome to this wonderful day where we are looking after the OPEA week celebrations. Uh, the project OPEA, which is the open standard for a platform for enterprise AI, started about a year back, and we are here to celebrate the first anniversary of the OPEA. And through the week, we are going to conduct multiple such events across the globe. This is the India Lake, and for the next few hours, you guys are going to get a lot of updates on what's happening in OPEA, about the state of OPEA, as well as what's coming next. So I'll give certain ground rules and some housekeeping rules. Please be on mute in case you're not speaking, which I think everybody has done. Thank you very much for that. If you have any questions or queries, use the chat window to put your queries, and we'll definitely try to answer your questions and queries. And another important tip to all our presenters that we are timing the sessions and we'll give a heads up on your time as it comes to close. So please stick to your times so that we can get into it. So let me give you a quick agenda for the day. We have multiple sessions coming up. So we'll start with a quick keynote by Malini Bandaru. She's a senior principal engineer at Intel, looking after cloud native areas. And she's been working on OPEA since day one, and she's currently the chair for tech steering committee for OPEA. And we'll also have Rama Karamsetti after that, and he's also a leader in Intel, looking after enterprise AI products in our AI group. And he's also going to talk about what's coming up in OPEA next as we look after the new releases coming this year and new areas where OPEA can really help anybody who's looking after GenAI projects. So without further ado, I will hand over the reins to Malini, and we are requesting her to start. Okay, Malini, over to you.
Yes,
Thank you,
Sachin.
everyone. So Rama's going to share the slides. So Rama, will you share the screen?
Coming up. All right, Sachin, we made a minor change. We are going to present this together, the keynote as well as what we look forward to between me and Malini. You guys let me know when you see my screen here.
Ta-da! The screen is up. Yes. Hello, everyone. I'm Malini Bandaru, a senior PE here at Intel. I work mainly in open source in cloud technologies. Rama, you want to introduce yourself?
Hello, everyone. I'm Rama Karamsetti. I'm a director here in Data Center AI Group at Intel. I've been here with Intel quite some years now. I'm responsible for the product definition and roadmap and strategy for enterprise software here at Intel currently.
So welcome, everyone. We're very delighted to have you here. So a little bit about myself. I am focused on confidential compute, on AI, so things like security and performance in the cloud. So any hardware product we develop, we try to enable all those hardware features for cloud usage in bare metal and in virtualized environments. I've been working in open source for over a decade, working on projects such as Kubernetes, EdgeX Foundry when I was looking at edge use cases, Enterprise AI, our OPEA project right now. And it all began with OpenStack when I first said, hey, our servers are only 30% utilized. They have to be a shared resource. And other than that, I have got a PhD in machine learning. I'm a STEM coach, an avid gardener, about 30 plus patents right now and things like that. So also a KubeCon and Open Source Summit Program Committee member. Handing off to you, Rama.
Thanks, Malini. Yeah, well, I'm not a PhD. Yeah, I don't know if I'll be living up to your resume there, Malini. Been with multiple different divisions. I've been a leader running edge inferencing groups, smart buildings, industrial groups here at Intel. I do have a master's in electrical engineering and then an MBA. I've been spending most of my last 10, 15 years running businesses, products, and anything that's got to do with making money for Intel rather than developing the product. So the last few years is when I moved again to creating software products definitions and software product solutions, which and the last few years is when we started the efforts of last 3 years is what culminated into Open Platform for Enterprise AI, which we launched last year, and we'll go through a little bit more in the slide deck. All right.
Okay, yes. Okay, so this is a boilerplate slide saying, we're all about inclusive competitors work in open
Nalini,
source. Yes.
we can't see your slides yet, so if you can share the
Wow.
screen, yeah.
What? Hey,
I can
Sachin.
see it, Sachin.
Sachin, we can see it now.
Sorry, my bad. Go ahead. Sorry. Thanks.
Okay, thank you. Okay, so this is just a boilerplate slide saying, we're all part of Linux Foundation in this OPEA project. Everything is inclusive, open, things like that. Next slide, please. Okay, so let's start at the beginning. How did OPEA, this open platform for enterprise, begin? It recognizes a problem in the market, and that Gen AI, it's all the thing. It's AI everywhere. It's rapidly moving, lots of innovation in this space, but unlocking its potential in the enterprise has been difficult. And this stems mainly because of a skills gap. It also stems from the cost, and everything in the enterprise has to be also secure and scalable and things like that, 5 nines type of availability. So those were the sort of issues that are stemming and staunching this adoption. And OPS seeks to address those and democratize the adoption of GenAI. And with all this, we started off at Intel with a white paper. And another very important thing is we wanted to also highlight that even if you don't have a very fast GPU, it does not keep you out of the game of using GenAI. You can use your CPUs, you can even use your PCs, and you can even do it even better with an AI PC. But we wanted to establish and demonstrate that it's not all a GPU game. We also wanted to establish that there are multiple industries with different needs in there, that, if it's a finance or healthcare industry, their requirements for security are more serious. There's also the fact that, a lot of industries have voluminous amounts of data. How do you digest them? Because we're in an information glut. So they're different users. And with that, what we did is after we created that white paper and this intention to demonstrate other hardwares are relevant in this AI space, we constructed a technical steering committee for OPEA. And today's committee has 10 members, and I'm very happy to tell you that AMD is a part of this project. So it's not just an Intel hardware play, but we're also integrating with our competitors in this space, which is AMD with their GPUs and their CPUs. And of course, we test things against NVIDIA hardware too. So with that said, the TSE also represents the finance industry through Amar, who's from Fidelity. Then we have Docker, from the container space. We have Red Hat, who's an enterprise vendor of operating systems, platforms for AI, and so on and so forth. And then we have ISVs such as, CDW over here. So Kerr, who's my co-chair on the TSE, he comes with an AI background and I come from a cloud background. And why do we want to bring both of these? Because Gen AI is not just about AI, but it's also about production scale deployments. And that means it's a cloud play too. So with that, we have a year's worth of TSE members collaborating, and I'll get to the vision in a minute. But before I go further, there are links on this page that say how to get to the TSE, how to join the TSE meetings. They're monthly. They're held on the first Thursday of the month. And more importantly, we're reaching this 1-year birthday, right? And the TSE is also reaching that 1-year birthday. And we're going to have re-elections. And I desire, hope that somebody from the India ecosystem will join the TSC. So please consider it. Tell us how you can collaborate and help push OPEA forward and help to democratize AI. So please nominate yourself, send us email, and let's consider it. And I'd like OPEA to be a global project. So we're going to get some folks from China and, having India representation and then Europe representation would be awesome. So there's also a calendar. There are other work groups that you can join, like the security work group, the end user work group, because our documentation can certainly improve. And anything at a production scale also is not just a POC. It has to be secure, but it also has to be evaluated for accuracy, performance, scalability, and so on. And that's where the evaluation work group fits in. And given that this is a field where there's a lot of innovation, we also have a research subgroup. And of course, never forget security. Next slide, Rama. So with the TSC, we created a vision statement for OPEA, and that's the high level goal. We want to enable enterprises to develop and deploy GenAI solutions powered by an open ecosystem. And what do we mean by an open ecosystem here? Any OS works, any hardware works, any open source projects work. So it's not just an NVIDIA play or an OpenAI play anymore. So it's not just one hardware or one vendor. And you can also host your own models on your own desired hardware or your desired CSP and achieve the goals that you have, whatever they are, like in latency or in throughput or in cost per token. And then, of course, to your domain of use, like is it finance, is it healthcare, whatever. And so we also want to integrate security into it, scalability, and of course, efficiency and things like that, agility. So let's just focus a few more minutes on these words. What do I mean by agility? We have in OPEA some GenAI example pipeline. So you can take those and then customize them. So with that, let's get into the OPEA architecture that Rama is showing here. First and foremost, look at the bottommost layer of those green boxes. We call those our microservices. Why? Because OPEA is a cloud first play. Everything is a containerized workload, recognizing that we're in this cloud native, ecosystem in day of today. So the LLMs, the large language models themselves are served through a large language model inference engine, and that's also containerized. And we have multiple solutions there. You could use VLLM or you can use TGI. So there are options there. Again, it's open. A lot of the data can especially your domain data, you want to bring it in yourself because it's proprietary. It's not upstream somewhere. It's not integrated into a model somewhere. And that's where RAG comes in. Okay, so bringing that RAG, we have this data prep component. That's the second item on the very left. And then, of course, there are all the standard pieces in any AI pipeline. Like there's embedders, there are retrievers, there are re-rankers when you have multiple things that seem relevant. There are guardrails to like check that the input, is it sane? Is it off topic? Like, am I asking about cancer or a political party when I really want you to ask me an IT question or some other finance question? So guardrails. Then to even improve things further, we have support for graph rags. And then the future is all about agents, having entities do these tasks in an autonomous fashion on your behalf so you can save some time for yourself. And then eventually there's fine tuning. And we've not got into a lot of fine tuning just yet, but that's for the future, and that's why the box is colored differently. Then layered on top of this, how do you connect those microservices? That's where the mega service comes in. There are also other popular open source tools like Haystack, LangChain, Llama Index. And then to further democratize all this, we have this GenAI Studio that allows you to do no code, low code drop in and make your pipelines. Okay. Then once you have your pipeline, you have an application. So that's the topmost layer, GenAI use cases. And we have about 22 of them right now. So that's a little too many. So we're focusing on 8 of them. So you can see there's a lot of enthusiasm from our developer community. They have a lot of contributions here, including an avatar bot over there. But we'll focus on 8 of them. And they're things like chatbots, document summarization, code generation, agents, code translation, language translation. So those are the top 8 ones that we will be focusing on over the course of this OPEA, and definitely doing a lot more QA and validation on them. So if you looked at this chart again, the base layer is the microservices. Think of them as your beads. Your middle layer is where you combine them with different glue or string or gold, whatever you want. And at the top layer, that glued string is your solution. Okay. Next slide, please. So with that said, how do those 3 layers translate into the OPEA GitHub repo? We have a bunch of sub-projects to keep things a little modular. So those beads, like I mentioned, the GenAI comps, they're the very leftmost top box we have. The GenAI examples are the samples that we have pre-constructed for you, like the document summarization, the chatbot, etc. Then, since everything has to run in a cloud somewhere to reach production scale for enterprises, we have the GenAI infra that has Python scripts, Ansible scripts, Terraform scripts to deploy, infrastructure in a CSP of your choice. Also, things like, how do I integrate identity and access management, things like Keycloak. There's also information there on how to use a service mesh. And there'll be also other operators and drivers eventually. Okay. And we'll talk about those operators in a little bit. Last but not least, in the top row, we have GenAI evaluation, like how well does this pipeline do? How many instances do you need of a certain service to achieve a certain level of service? Okay, so do you need 2 instances of a language model? Do you need 1 instance of something else? And do you need 1 instance of it running with a certain amount of resources? So those are the sort of things that we come across when we're doing our GenAI evaluation for different performances. I earlier mentioned the GenAI Studio for low code, no code. We have a large group of folks using OPEA in China, and there's some differences there. So we have a sub repo for China. Basically, the models that they use are a little different. The embedder they use is a little different for their Chinese language. So there's some differences there. Further, they can't access GitHub and they can't access the Hugging Face repository. So there's some mirrors over there. So that's the little differences there. That's something we can also customize for India if we want to use the Indus model or some other model or whatever, okay? Now, all this is great. We can run in any cloud anywhere, but what about some other special glues for certain clouds or locations? So that's where we have the enterprise RAG, where we have certain other components to connect with, say, Watson X or an IBM cloud or an Amazon cloud. And you can just lift and drop them over there to have your production deployments. And the most important piece is docs, and that's another repo. So with that, I hand off to Rama.
Thanks, Malini. So one key thing in what Malini described for microservices is everything we are describing here, we are creating this in an open source manner, partnering with people. As Intel, we can only go so far. And we know that as the market is changing so rapidly, we are bringing in all of our ecosystem partners, customers, and everyone to come join us and develop microservices, develop mega services, develop pipeline builders, create endpoints, okay? And then work with us closely and bring that back to what we have as OPEA repos that Malini described here, okay? So these are all OPEA repos in our GitHub, and any partner and any customer that's working with us that brings in either a component level contribution or an end-to-end solution or a benchmarking methodology or a specific application that they'd like to build, right, are all coming back up to OPEA. So in the process, we went in and started working with multiple of these companies, okay? So some of these are like Malini described, right? They're experts. Some of these are experts in vector databases. Some of them are experts in embeddings. Some of them are experts in guardrails. If you look at the entire list, though, you'll see that you have all the way from component builders to system manufacturers, system builders, to system integrators, and even end customers in this list. Okay, so and that is the beauty of what we're trying to do with Open Platform for Enterprise AI. We are not trying to come and say that here is Intel making up a bunch of things, go use them. We are saying, hey, let's work together. We know that we are certainly good with certain things, and we know you as partners have experience with customers, and you have been developing certain things with the customers that are better than what we are doing. So let us bring all of this goodness together and make the best solution out of it by creating the component level, mega service level, the end-to-end solution level, or even infrastructure components that we bring in. Okay, so for example, if you take the Redis, Milvus, and could be a few other quadrant. Yeah.
Yeah, it's
A
right
few
in
other
the
data.
second line. Yeah.
Okay. Yep. So we have certain players that are really good with vector databases. We have prediction guarding here that is helping us with our accuracy. So with all this in mind, we have gone through a lot of work in the last year, and then we'd like to show you where we are heading to going forward. Okay, so there's a few things that we'd like to highlight. So all of last year, like Malini described, we did work on 22 different use cases. But if you were to bucket them together, right, some of 10 to 12 of them could potentially fit into the chat Q&A bucket. Okay, and then we have code generation, we have code summarization, code translation, we have document summarization, and this year we are looking at certain new areas. We looked at document summarization last year. We are going to look at document creation this year. Okay. We looked at standard RAG procedures last year. We're going to look at advanced graph RAG features and capabilities this year. We looked at component level manual pipeline building and workflows last year. And this year, we're going to go look at agentic flows. How do we have complex agents built on top of OPEA components that cater to the market that's currently out there? Okay, if you look at any big player out there, everyone's trying to go generate or create a path to have an agentic flow. Okay, and we are going to focus a lot more on the GenAI Studio, which is mostly going to be a no-code, low-code approach for us to go and develop end-to-end solutions. And there are certain certain quantization methodologies that we're looking at to help improve with fine-tuning. Okay, so that said, if you take a closer look, right? So we currently have a version 1.3 out to be released in April. We just about are working on it. Okay. In here, if you look at it, so the agentic flow, we have split it into multiple different phases. In this phase, we have an agentic flow that handles multiple different conversations, multiple different contexts, and still keeps relevance and gives you responses. In the next phase, we are going to focus on having human in the loop. What if I'm going to look at responses from agentic flow, and what if a human goes and tries to go change it or fix it or change the agentic flow? Okay, so that's what we're going to focus on. Similarly, we have had chat Q&A capabilities built in last year, and now we have an agentic Q&A built in that is ready for use. Along with that, we also created a specific agent that is helpful for finance FIS industry primarily, wherein it focuses on data prep. It focuses on what is more important in the finance segment. How do you make sure it is secure? How do you make sure it is what do you call isolated or air gap within the system or within the facility? How do you make sure that the handshake between different components is not polluting any other information? How do you make sure you have personally identifiable information secure, right? So all of these pieces is what we're trying to go and build in our finance agent, so that when you guys come in and partner with us and go to your end customer, that's a bank or that's an end customer that's working on finance data, right? It's going to be much easier for you to create POCs, show value, and come up with solutions that run on Intel. Okay, and then we also enabled VLLM. I mean, it's the most famous model serving that's out there right now. And then we do have complete support for VLLM this year. Okay, and last year we worked on LangChain and Llama Index up until the beginning of this year as terms of framework support. This year we have also included Haystack as one other framework that we could support. Okay, so going through this list, right? If you look at what we're trying to do is every little component that Malini described in the previous slides. With components, we have certain things that we are bringing in. In examples, we are bringing in certain new features and capabilities. Similarly, with the infrastructure, we have certain more things coming in. I know we only have 5 minutes left, but what I'm trying to drive here is we want you guys to come work with us and tell us tell us that, hey, Rama, you guys are working with a finance agent, but here in India, the market's a little different. We are looking at a specific different segment or a specific different area that needs more focus than a finance agent primarily, right? If you come and tell us that there are 10, 20, whatever number of customers looking for it, right? We will come and we can see how we can flexibly change some of this roadmap. So we need your input not only in understanding the market, the use cases, the problems, but we also need your input in understanding if we are developing to the right roadmap and help us change our roadmap. So the beauty of open platform for enterprise AI is we are very agile and we want feedback, we take feedback and we change our roadmap on the fly. Okay. So, and that is one of the primary reasons why Malini was asking for people to come in and then create or have someone to come in and join us in the TSC elections. So we need India representation. We need folks who actually work on the ground out there to come tell us what is right and what is wrong so that we can develop the roadmap using our TSC members' feedback as well as what we see in the market as well as what you bring to us into our sales account teams. Okay, so that said, we also have a little more detail on this 1.3 release. I did talk to some of this, but there are a few other features with respect to observability, with respect to the user experience. I mean, since we only have 3 minutes here, right? We'll ask for you to come reach out offline. Our emails and our personal information is shared along with these decks. Please reach out to us, talk to us, and ask us what you need to know. We can go either deeper or we can go higher. We can go about use cases. We can look at what needs to be done. So that said, here is some more content and some more links that will help you. There is this AI software catalog that will link you to what we've been doing. There's some videos that describe OPEA and what these microservices are, and one example link that's out here. But if you go to the github.io here, you'll find all sorts of documentation that's going to help you. So once again, to repeat what I was, or summarize what I was trying to say, right? Come join the project. Okay, you can contribute.
Yes, please come. It's your project. It's our
Exactly.
project. And influence it at any and every level, like through code
Yeah.
contributions,
If
through issues,
absolutely.
bug filings. You don't have to even be a TSC member. Everybody is important. Everybody counts.
So yeah, come join, contribute to components or use the components. Create end-to-end solutions or use our end-to-end solutions. We are not going to define how we are going to work with us on this project. We just want more and more participation. We just want more and more eyes, and we just want more and more brains to look at this and shape this going forward. Okay, we being at 1 year time frame here, we would love for that integration from a different geo. We would love all of you guys to come and look at what we already have and develop from here. I also have one more slide here with a QR code. You guys can scan this in case you're not getting all the links from all the previous slides. You go in here with this QR code, you'll be able to go into our main page. And from there, you'll be able to go figure out what's happening, where we are, what the calendar events are. Every piece of content that we shared in our slide deck here, you will be able to reach through this QR code again. And all through this week, we have multiple different events for different geos. If you have friends in other geos, please ask them to join us in our EMEA event or the US event. And on Friday, we also have a hands-on lab being demoed from our evangelism team. Come check it out, look at it, and then tell us what's good and what's bad. I'll stop there. Malini, want to add anything, please?
Nope. Thank you for joining us.
Yep, absolutely. Thank you guys for joining us.
And we'll follow along in the chat to respond to you if you have any questions.
Awesome. Thanks, Rama. Thanks, Malini, for the wonderful kickoff for the OPEA Week Intel Lake. I'm sure there are a lot of queries and questions and interest coming up, and we are seeing that in chat as well. So, folks, feel free to raise your questions or queries in the chat, and we'll definitely answer to it as we scroll through the chat. Just to have a follow-up conversation, we'll be planning a series of OPEA workshops for those who wants to do hands-on action on OPEA, as we are discussing a lot of nuances today, later during the year. So watch out for those emails in your inboxes when we're going to announce the OPEA workshop. So be connected, and then we'll let you know more about the OPEA hands-on stuff. All right, so moving on to the next session. Next session, we are going to discuss a very interesting topic about how we are going to use some of the use cases and showcase the capability of OPEA. And for this, we have a topic which is the future of interaction, specifically working with machine to human as a conversational agent, and then creating that engagement model. So to do that, we have Rama and Jeff sharing the presentation with us. So Rama and Jeff, if you can carry on with your session.
All right. Thank you, guys. Thank you, guys. Jeff, are you online?
Am.
All right.
Can you hear me okay?
Brilliant. We can, Jeff. Is it okay if I share?
Sure.
Or if
yeah.
you have it open, yeah, go ahead, please. I'll stop sharing here.
While Jeff brings up slides, he is head of global consulting at Indigo Slate and leads a team of senior technology strategists and consultants, engineers, and has a rich experience of working in the IT industry. And he has a passion to deliver high quality enterprise solutions on OpenStack. So thanks, Jeff, for joining us today.
Yeah, thanks for that, Sachin. So a little more background there. When you guys looked at what we showed in our partner slides, right? We wanted to make sure that we were not just coming in and talking about it from an Intel viewpoint. We wanted our partners, and Zensar has been a key partner working with us from day zero, actually even before day zero. So some of the definition we had in the original launch is feedback that I personally got from Zensar, as well as a couple of other key TSC members that you saw earlier. Okay, so we wanted to have Zensar come represent what they've been working on and what they've been doing, and how we can work together as Intel and Zensar, creating solutions for generative AI. So Jeff, please.
Awesome. All right. So we're going to try to get this all done in 20 minutes, including a demo. So I'm not going to read each slide, but I want to give you a high-level overview of the solution that our AI team within Zensar has created in conjunction with OPEA. And we really view it as flipping the chatbot on its head. Typically, we build AI-driven chatbots as respondents rather than those that take the lead. And so what you'll see here is why we created a reverse conversational engine on having a chatbot that actually leads conversations and really helps that experience that we want to build for our customers. A little bit of it just real quickly about who we are. If you're looking at my email and all that kind of stuff, I live under a sub-brand of Zensar called Indigo Slate. We're the Experience Studios. And so under Zensar, we have a product studio, which is Foolproof. We have a marketing and consulting studio that is Indigo Slate. And then we have our end-to-end engineering. We really are driven around the idea of experience-led, deep engineering focused, and long-term engagement. So everything that we build comes from that lens. So everything that we're talking about, it really comes from what we call Triple E. All right, but enough propaganda about us. You've seen this slide. We want to make sure that we're reinforcing. GenAI is emerging rapidly. Enterprises are struggling to realize that value of how do they apply this in production. How do they embed this into your applications? And so we've tried to build a solution that can be added to websites, can be added to mobile apps, can be added to whatever our customers are trying to do. And we'll dive into some of those use cases here in a little bit. All right. Rama, I don't want to take all your thunder.
No, no worries, Chef. Yeah, no. So the group here just got an overview and listened to us talk about our mission and vision. So I think we could potentially just go through because we only have 15 minutes left. Yeah. So yeah, the group here just understand that this is the basis for all of our GenAI solutions. This is how we started creating our components and end-to-end and the mega services and end-to-end use cases. I'd like you guys to have a mental picture of this, and we'll show how Zensar has an implementation of this with their what they call as an informal name to it as reverse chatbot. Yeah, Jeff, please go ahead. Walk through your head, please.
All right. So why did we approach it this way? Now, as I had said earlier, most chatbots really are designed to be respondents. And the interactions aren't always well structured. And they tend to be more casual. And let's be honest, we've all had the chatbot experience that was less than ideal. A lot of the chatbots are built across static decision trees. We've all fought the FAQ bot, where it was all pre-programmed, and if you did anything beyond that, it was a struggle. Most chatbots weren't using predictive modeling so that it doesn't anticipate missing information or prompt the user for additional details. And it struggles with correlation of data across multiple conversations. There doesn't tend to be that memory. And so, we've seen those challenges. And then that continual learning. How do I take previous conversations and bring them forward? And so when we set out to build this reverse conversational engine, these were the challenges that we wanted to overcome. Now, from a use case perspective, where do we see this being utilized across our segments? We see it active in the field service, being able to quickly onboard field service workers, being able to walk people through solutioning, customers being able to be guided through self-installations, whatever the case may be. Regulatory data collection, making sure here you can tell that I am in the States, and this is a big week for us. Our taxes are due at the end of the day of tomorrow. Unlike most industrialized countries, we have to fill out our own tax forms. There's a lot of mistakes. And so we could see a use case where this reverse chatbot could be utilized to make sure we're not making mistakes, we're not missing data. Being able to onboard customers very quickly. In the demo, you'll see it in the healthcare screening, being able to be an extension or an extra set of hands in a clinic, hospital situation, and can be used across HR, employee engagement, those types of pieces. So those are really kind of what we are looking at from a use case. But again, these are just ones we've thought of. They can expand. So how do we set out to do this? Well, what we wanted to do is, how do we take the existing large language models? How do we train them and evolve them to where they can take an active lead rather than passively respond? So we needed to be able to integrate all of the memory, COT, session management, all of those pieces needed to be bundled up in a way in which we can pull legacy or historical data, other data silos, plus what they're hearing from the user, and really build all of that together so that we could build a seamless engine and really have a paradigm shift on, we want this bot, this agent, to be a not only active, but a proactive participant within the conversation. And so unlike a lot of chatbots that wait for you to ask a question, this one actually starts the conversation and drives the conversation and does prompts to get the required information to come out with a positive outcome. And it does that through structured and semi-structured data collection of those responses that the human is giving it. And because it's an iterative process and a learning process, we really want to drive those good outcomes. So what does that look like from a block diagram? We usually do it in these 7 steps. The reverse conversational engine initiates the conversation, typically based on predefined triggers. That's just the best way to do it. We do it from a system of records. We do profiling and context building. So it's going to retrieve any relevant information from its long-term memory. This is key because we really want it to drive a realistic conversation with a human. It will then generate those questions to be able to get any missing data. We're using a chain of thought mechanism here. And then constantly we want the users to do some input. We're going to do some analysis that can be on sentiment analysis. We can try to see if it's getting frustrated. Is it not understanding our questions? Whatever the case may be. And then we want that action and response. So based on the input and the context, the RC performs the action, updates the records, initiates any other workflows that may be behind the scenes. And then we want to make sure that we're capturing it and that it is iterative, that we are making sure that that's doing learning and improvement on those. So we want the agent to, have its lessons learned and improve it in each subsequent session. And so as we're looking through these types of pieces from a model, the way that we were walking through this from an advanced perspective, if we look at it from the ecosystem lens, there's the system of records. This is really what we're using as our primary and authoritative data source. Sorry, words are hard. That could be a database, that could be a CRM, whatever system that is needed. There's conversational history and summary storage also going on at this point. We have our orchestration and management. So that's going to be what we call the conversation orchestration service. It's the main entry point, handling incoming queries. It's routing through the system. It's our dispatcher, ensuring requests are processed correctly. We have a dialogue management service that manages the conversation flow, keeping track of the user's goals and intent. Then behind the scenes, we have our content and pre-processing. The pre-processing clean and prepares the incoming query for further analysis. The context engine is what we're utilizing to extract relevant information. It's going to then pull in things from conversational history and systems of records. It's basically trying to build the user's current state and what the intention is. And then we apply the intelligence layer. That's our dialogue management service. This is where it's pulling in from our best of breed LLMs that have been customized for the use case. And this is what we're using to come up to an outcome through the conversation. We have a dynamic query generating service, again, working off of the LLMs to formulate specific queries to pull in any missing data. We also have built specific processing guide rails, personalization to make sure that we're always compliant with any local regulations or national regulations. We handle both short-term memory in session. That's going to store all the immediate so that it's performative. We have long-term memory that persists the user preferences, past interactions, relevant data and personalization, future conversations, session management, etc. Whew, covered a lot in that. All right. So when we start looking at this,
you only have 5 minutes.
Oh, Jimmy. All right. So more important then, to me yapping, I want to hand it over to one of my architects. Prashant, are you on the call?
Yes. Hi, everyone. Hi, thank you. I am not having option to share my screen. Amma, so you be able to help me out? It says
if you
disable.
go to the bottom and click on share, it's just typical Zoom. Yeah.
Okay, it's enabled. Yeah. Yep.
So this is Prashant, who's one of our AI architects, and he's going to walk us through a demo of the solution.
All right, we can see your screen, Prashant. We can't hear you though.
You're
You
muted.
muted yourself. You muted yourself, yeah. Yep.
Okay, looks like yeah. Am I audible, Rama?
Yep.
We can
Yeah.
hear you.
Okay, great. Thank you for this. Yeah, I just want to first of all explain what this domain about. I think thanks for a great intro and then detailed walkthrough of what the solution is, Jeff. Right. So this particular solution we are working on implementing it for FDA. Right. So what FDA does is whenever there is a process called REMS process, which is risk evaluation and mitigation. Okay, whenever there is a drug related allergy a patient is going through, they are, as per norms, they are supposed to declare their symptoms. Okay, and this is a 4-pager document. When they get in touch to a call center FDA agent, the FDA agent should go ahead and collect all this information. There are close to 140 plus fields, and then they need to collect this information and then submit it into the system so that similar allergic reactions can be tracked for other users. Okay, so this is where we thought we can come up with a solution called reverse conversation engine, where a goal is assigned to an agent saying that you are supposed to collect all this information from a patient by through a natural language interaction. I'll play a very quick demo. So patients.
So Prashant, the voice is very low. Why don't you just speak to it when it's running?
Voice is very low, is it? So okay,
Yeah.
okay. I will try to explain. What happens is the REMS chatbot initiate the conversation, and then patients gives their patient ID from a system of records. All the patient related information is prefetched. Okay. The next step, if you see, the system of the conversation agent asks some questions on what is the severe symptoms and then what are all the different labs tests they have taken up, etc. So user here is trying to explain, okay, like how we get it. Maybe if we get a what to say appointment, we go ahead and talk through to a doctor, right? See what went on, what is our timeline, and then what are all the different allergies which we are going through. It's not a sequential, it's just us conversing with a bot, like how we are going to converse with a human, right? So from this answers, the system will automatically identify all the missing pieces, try to fill in the forms, and then regenerate the question which is dynamic and which is addressing the other parts of the outcome. So this is the core part of it. If you look at it, the questions was, the answer was processed by the system. It said from when, what was the date when the report was submitted, and then I'm saying that 26th September 2024, and then other questions are being asked, right? And then blood test on 16th, this is when the blood test was taken. So all of this information will be processed and then will be used to pre-fill this form. End of it, I think the system will auto save the responses once it has collected all the information and then push it to a downstream system. That's where human in loop comes into picture, and then human will be able to verify, validate the given information, see if there is any other missing information to process it further, right? The core part is agent is initiating the uh, agent is triggering the right questions and then sequencing the questions in a dynamic way, and users are able to respond to the right questions in their natural language. Okay. Over to you, Jeff.
All right. Thank you. If you'll stop sharing your screen, I'll wrap up.
Yeah, I think my screen share is, yes.
Up at the top where it says,
Yeah.
thank you. All right, so the deck is available post. There are other slides on there. But basically, again, just to recap, what we attempted to do here, instead of having a chatbot that is designed to respond to the human, we've created a chatbot in which it drives the conversation, and it's specifically looking to get any missing data to be able to help fill out forms, regulatory compliance, whatever the case. It can be trained and built for multiple use cases across multiple industries. We have built this internally. We are doing performance testing across all 3 hyperscalers and architectures. We've been working very closely with Malani and Rama on this, and we're excited about where the future is headed. So I'll take a pause, and we can take any potential questions. I probably have, 1 minute? Or am I over?
While you guys are coming up with questions, basically what Jeff's trying to say here is, as Intel, we did go and work on 22 different use cases, but that doesn't necessarily mean that we are covering the entire problem statements or our problems or use cases that are needed out there in the market. So Zensar partnering with us, and they came up with this application that says, hey, you don't come up with all your questions. You tell us where you are, and then we'll prompt you with a bunch of questions, okay? And thus they're calling it reverse conversation engine, right? And then now, once this engine's built, they are bringing this and contributing this back as an end-to-end example that can be fed into OPEA. Okay, so some of these components might be licensed as part of Zensar solution, but that's okay. That's the beauty of open platform for enterprise AI. You could have your licensed components, you could have your free components, you could have your premium or freemium components. Eventually, the goal is to be able to build the best solution. Okay, yeah, I'd like to just stop there and see if there's other questions here. Okay. Is there a YouTube channel? Okay, we'll answer those separately. Anything specific for Zensar? Okay, so Jeff, there's a question for you that says, what if a user submits multiple responses for the same query? Is it able to handle the response, or will it be hallucinating?
So it is a use case that we have tested.
Okay.
Prashant probably knows more on those results.
Gayatri actually responded, I think, here in the
Okay.
chat. So I just noticed.
Oh, okay. Hi, Gayatri. Thank you.
Hey, thanks.
And Gayatri is our practice head of this solution.
It handles actually. It doesn't hallucinate because we know the context very well. And if the user responds for multiple times with different details, then it basically evaluates it, validates it, and goes back to the customer or kind of the user to ask like what is relevant, because you had given these 3 answers or 4 answers, which one needs to be considered will be the kind of representation that we give, and it doesn't start hallucinating because we know that it is a kind of a templatized answer, and we bring in the right set of answer by having a reasoning and validation agent which has been built, which will basically look at your answers and then get back to the end user with the right set of, if it is kind of not able to figure out the right answer here. So it doesn't hallucinate. There is an agent for verification and validation across all steps, which validates all of these answers and then put it back.
Sounds good. All right, we are 5 past the time.
Let me just add one sentence. GenAI is like a foundation, a tool. But what you can do with it is your imagination. So here, Gayatri and all came up with like, how can I help users fill up a form that's complex and tedious and things like that, and make sure nothing is missed. Another way is you might have a form and you have a lot of documents coming in from a user, say they're applying for a loan. Instead of having to read everything, what if you could pull out the data from those documents and just fill in, like, this is their monthly income, this is their monthly expense, and then link to the documents that say, this is the income from their salary slip. So it's up to you. It's your imagination and how you can use GenAI to improve productivity. Thank you.
All right, so
Okay.
a lot
Thank
of
you.
Thanks.
and
Thank you, Sachin.
keep them coming. Definitely, we'd like to circle back with all the details. And as we have mentioned on chat, OPEA.dev has a lot of documentation and examples where all of you can go and check it out. So with that, I am now inviting Anish Kumar. He's a senior AI engineer manager at Intel, and he's going to take us through the next topic. And we're going to talk about how to really build and deploy AI agents with OPA. I think those were some of the questions the folks already asked. I think that would be a great session to follow up through. So Anish, over to you.
Thank you, Sachin. Hopefully my screen is visible, and for some reason the video is disabled, so I'm not able to enable my video. But anyway,
I'll just get your video enabled, not a problem. I'll do it in a minute.
Sure. So meanwhile, thanks everyone for joining today. Today we will talk about how to build and deploy an AI agents with OPA. We'll take up one of the examples. Before we get started there, So a brief introduction of myself. I'm the AI software engineering manager at Intel. I handle the Asia Pacific region, so where I help enterprise customers to implement and optimize their AI solutions right from ideation to production or anywhere in between. So my engineering team closely collaborates with customers engineering team to help them to choose the right hardware and software stack that can give the best results for a given use case. So at any point in time, even after this session, if you need any help with the free consultation that Intel provides, please feel free to talk to us and we will help you in designing your AI solutions. So that said, we'll move to the agenda. We'll talk three things today, AI agents briefly, and then AI agents with OPIA, and then we'll conclude with a demo. That's all. It's very simple, three things. So what are AI agents, right? I mean, we have been hearing a lot of LLM stuff. Everybody is aware of LLMs, the large language models. So large language models is like there's a model. You might use some kind of a framework like PyTorch or any of this VLLM or any of the stuff to query the model and get the output. That's an LLM system. But then there is also something called as workflows, right? Workflows is like you might have multiple LLM systems, and these LLM systems are connected to tools. Why do you want to connect them to the tools, right? LLM system individually is of very less use when you are actually considering an enterprise scenario, right? So enterprise scenario works with a lot of other systems. You might, like for example, in your own office, you might have a SAP implementation, you might have an HR module, you might have a finance module, or maybe SharePoint or MS Word and all these different modules, right? And you want your system to interact with all the six, maybe collect some data from something else, process it, and then based on that make a decision, and then send out that information to some other tool that can actually process or display it or consume it, right? So workflows, what it does is it's actually takes the input from the user, and then based on certain predefined rules, the path based on the question that you ask, there's a predefined rules that is set, and that rules will direct the query to a particular tool, and the tool will consume it or might be process it further and then spits out the output. That is useful to a certain extent for certain use cases where you know the path is very clear. But many of the times, like for example, the previous use case that you were the presenter was showing, like the filling up the FDA form, there might be chances that based on the query, based on the response, you might have to redirect dynamically these agents that are the tools that you might want to use, right? So in that kind of scenario, we propose to use AI agents. So how does it differ from a workflow? So workflow has predefined path. It has to go through the path. This is the input. Go to this path or this tool or this thing, right? But AI agents can make real-time dynamic routing decisions. And there'll be a set of tools and there's a set of LLM systems based on the input, based on the context, based on the scenario, based on the current situation. It might actually dynamically route. So it might end up collecting the information, determine what needs to be done, and then execute that decision. Finally, after executing, it might get a feedback feedback, and based on that feedback, it will try to learn and then improve. So as and when you keep using it, it keeps learning it and it improves it, right? So if I had to summarize AI agents in one shot, remember three things, right? It collects data from its environment, all kinds of data, the user input, the context, maybe data from some other databases or some other tools like web search or correct contextual information, then determine what is the best action it needs to take, right? Based on its previous training data and things like that, it might determine certain action is the best for this particular context. Then it will try to execute that action. Once the action is executed, it learns from that feedback. What was the outcome? Whether the outcome was acceptable for the end user or it was negated or whatever it is. It takes that and learns from it and loops back into the chain, so that with very minimal or no human intervention, the AI agents can start performing tasks that are kind of a day-to-day task, like what the previous example was shown, filling up that huge form, FDA form. It's like, I think uh, the presenter mentioned almost 120 different fields are there, right? So we have to fill up all those forms. It's a very cumbersome thing to fill it up. But if somebody is querying and interactively collecting all this data and then filling it up, it's actually kind of eases your entire burden, especially for a lot of enterprises where this needs to be done in millions, right? Consider filing income tax returns, right? Millions of people will be filing income tax returns, and this has to be automated. If it's automated, then it lessens your burden. So these are some of the there are a lot of use cases that are coming up. So standalone LLM system is of very little use. Combine it with AI agents, understand if the use case demands that, and if there's a good return on the investment, implement AI agents and automate a lot of your stuff, right? So that way, what are the benefits that you're going to get out of implementing AI agents? One is efficiency. Definitely, a lot of manual processes can be automated. That increases the efficiency. Like how much time it takes to actually fill up that form or do the task can be reduced drastically using AI agents. And the customer experience is one critical thing, right? Like, instead of manually filling that boring form, if you are able to have an interaction, then the experience the final customer gets is better, right? You get a better customer experience. And the other thing is consistency and accuracy. Since it's all machine driven, there's always a consistent way it actually goes through, and there's an accuracy that is maintained. And other main important thing is availability. Computers doesn't get tired, right? I mean, then you can have it 24/7 running. You don't have to have a manual person, a call center being running there in a fixed 8 hours time slot in a window in a day. Instead, you can have a 24/7 agent. I think most of you would have seen most of the banks or any of these customer facing enterprises are already replacing their manually driven chatbots or call centers with a lot of these automations. They might not be purely AI agents, but slowly they are getting there. Currently, there might be all workflow based, but slowly there are a lot of AI enterprises are implementing AI agents to make them availability 24/7. It's available. And other big thing is data driven insights. Like I said, it actually learns from the interactions and keeps improving, right? As and when the context changes, as and when the scenario changes, it learns from that things. So you have an system that is intelligent, that keeps learning from its past experiences and improves. So and it's all driven by the data that it has. And finally, the scalability. It can handle large volumes. Let's assume that if the entire India's income tax returns has to be handled, imagine how many people would be required to handle that, right? Like, uh, there are approximately 2% of the Indian population pays the income tax. If 2% of the population is um, filing the income tax returns, that means almost more than 200 million people are filing income tax returns. If more than 200 million people are filing the income tax returns, how many manual people are required to help them to file those returns. If that can be scaled, right? If that is all driven by the machines, then it's the scalability. You can just have a couple of servers and suddenly it can serve millions of people, right? So that way the scalability is also scalability based on the demand. You can increase the number of servers that are serving that particular request, or downscale it based on the demand, right? Usually in India, June, July time, when people start filing the income tax returns, you can scale up your servers, and during the dull period, you can scale down, so that way you can keep the cost down. So these are all some of the benefits. I think are pretty straightforward benefits of using AI. So at any point in time, if you have any questions, please put it in the chat window. I might not be able to respond immediately while I'm talking, but definitely I will try to respond after this my presentation. Then I'll have a lot of time to respond. So please feel free to ask your questions while I move to the next. So next we'll talk about the OPEA agent overview. So OPEA, like our previous presenter said, it's all based on microservices, Dockerized, containerized, right? It's all designed in such a way that it needs to be deployed easily in the cloud. So agent microservices runs planning, action, observation, or reflection, whatever we talked about in the previous slide. Basically, it runs all this logic on a CPU, and like an LLM microservice, there's an LLM microservice which you can run it on a Gaudi AI accelerator or a GPUs, or you can, if it's a smaller model, like if it's a 20 billion or a lesser parameter model, you can still you can actually configure it to run even on a Xeon machines. And then agents are equipped with multiple tools to complete the task. So here in this example, for example, there's an AI agent microservice that you can see, and that has a web search tool. There's a private file retrieval tool. There's SQLDB tools and other tools you can keep adding. I'll show you one example where we dynamically add one tool into the existing agent, so that the tool is able to answer that question more relevant, more accurately when it gets more contextual information, right? We'll explore that. So before I get into the demo, probably I would like to show certain benchmarking numbers that might be relevant, so that it gives you a fair idea why agents can be better when compared to traditional just LLM or LLM with RAG. I think many of you might be aware of RAG. RAG is retrieval augmented generations. So let's see how this benchmarking works. There's a comprehensive RAG benchmark that was introduced by Meta. Meta is the parent company of Facebook and Instagram, or the Llama series of models. So they introduced a benchmark called Comprehensive RAG benchmark in 2024 that contains simple fact questions. There are 7 types of complex questions, such as comparison, aggregation, and set of questions to test the reasoning and synthesis capabilities of RAG solutions, right? So we tested that with a conventional RAG, where a conventional RAG is you have an LLM model and implement a simple RAG, maybe by supply a PDF or a Word document to that, and then check what is the accuracy of the results that you get. If the third column that you see, accuracy measured by Raga's answer correctness, so that actually points to if the value is closer to 1, that means it is almost close to human level accuracy, right? The more the value is closer to 1, that means better is the accuracy. See, in a conventional RAG with comprehensive RAG benchmarking, what we have seen is it gives you an accuracy of around 0.37. And if we implement a single RAG agent, it slightly improves the performance. Like there's one single agent, and then there will be a RAG implemented on that, and the agent will determine which particular RAG tool to use, right? So in that way, probably there's a slight improvement in the performance accuracy. Like you can see from 0.37, it slightly increases to 0.43. Now, there is another hierarchical multi-agent. What do you mean by hierarchical multi-agent? Hierarchical multi-agents are agents that are like, for example, there's a supervisor agent at the very beginning that takes all the input that is coming from the user or from any of the systems, And this supervisor agent will determine which agent is suited. There'll be a bunch of other agents under the supervising agent, and this supervisor agent will determine which agent to choose. It's a hierarchical multi-agent systems, and that multi-agent hierarchical systems is known to give you better results, right? Like based on the because even if you see that FDA form use cases, there'll be multiple types of questions being asked, which can talk about multiple things. It might be talking about the person's health. I'm just making a random prediction. I'm not a FDA expert, so I'm just trying to see making guess. Maybe the FDA form might be asking about the personal details of the user. Maybe it might be asking about his health, his current situation, right? What is his age and things like that? What are the medicines he's taking? And based on that, this all requires different types of agents which can understand things. But they, like, for example, if it's talking about the private details, maybe it needs an agent which is very expert in dealing with private information, right? Okay, I'm just running out of time, so probably I'll just, yeah, I think you understand that it needs a lot of different types of agents to perform a task. And you can see that, that definitely it gives you better results, slightly improved results at 0.54. And there's also one more benchmarking tool called, probably you can all use that. There's a link is also flashed in the screen. I can refer this benchmarking tools to do your own evaluation later on. And definitely SQL agent versus test SQL. Again, you see there's when you're using the agents, definitely there's more improvement in results. I'll quickly go to what is the value of OPEA agents over OpenAI agents, right? OPEA agents are open source, right? As the name implies, it's open source and free to use. There's more privacy with data models, and things like that, right? And for enterprises, with the privacy of the data, the information, a lot of enterprises deals with a lot of secret information or top secret information, confidential information. They need to protect that data. So definitely OPEA AI agents give you more control over that. It's compatible with OpenAI assistants, right? Because it comes with OpenAI based style REST endpoints. So you can easily unplug OpenAI's agents and replace it with this OPEA agents, because the API signature is all same. And then definitely it's a low code, no code platform, because everything is Docker, and you can just compose your Docker YAML file and get things going. Here is one thing, like I said, talked about hierarchical agent, right? There's a supervisor agent that is a React, and then there's a worker agent, can be a RAG that is talking to a vector database. Then there's a worker agent that is an SQL agent talking to an SQL database, and there can be multiple tools. This is a very simple architecture diagram. Probably since in the lack of time, I might quickly go through that. Like said earlier in the earlier presentation, each of those modules in this agent is all microservices based. Each is an individual Docker container. You can individually pick and choose where the Docker container has to run, on which machine it has to run, and how do you want to interconnect them. And there are definitely sample examples are already ready to use examples are given to you. You can readily use that and deploy it in your enterprise. So here is one example, quick example of an AI agent Q&A. Agent Q&A is one of the examples available in the OPEA GitHub repository. You can go ahead and deploy it. You'll see this interface, simple interface. Here, what I'm going to do is I'm going to ask a simple query. There's a database related to music albums. So I'm going to ask which artist has the most albums in the database. Query to this agent. Now this agent goes and searches the database. Since it has only the database agent as connected to it, it will go ahead and ask that search artist database, right? It will go and ask this database which artist has the most albums, right? It will form the SQL query by itself and everything, and it will come out with spit out the answer saying that the artist with the most album is Iron Maiden with 21 albums, right? So it all worked fine, great. Now probably I'll go into a more real-time information, right? Probably I wanted to have a real-time information on, I will go ahead and ask this particular question, right? I'll ask which artist has the most albums in the sorry. So I'll go ahead and ask. I think the video is slightly messed up. Just give me a moment. So here I'm going ahead and asking which female artist has won the most albums as Spotify in 2024. So it actually initially goes and it wanted to talk to the database. Sorry, I think the screen sharing was stopped. Let me reshare it again. Hopefully my screen is visible again, and yeah. So here I'm going to ask the agent which female artist has the most albums on Spotify in 2024. So this actually result was not there in the database, and we actually connected a new tool to the AI agent called search web search, right? Basically, it's going and searching the web. So it actually initiates a web search, and then it will actually go ahead and search the web and try to decipher what is the correct answer for the question that I asked. It is a very simple solutions that we are showing here, where it will search all the Spotify information and comes out with the answer saying that female artist. It used the tool called search web base, and the query was female artist with most albums on Spotify, right? And the answer it comes out with uh, Taylor Swift. I think the answer was Taylor Swift. It came up with the answer saying Taylor Swift. We can see here, it says the tools calls have mentioned Taylor Swift as the top global artist of 2024 with her album. So it went ahead and searched the web and picked up the relevant answer and came back to you with the answer, right? So you can now see that how you can actually improve your agents by connecting tools, connecting tools, different tools dynamically based on the situation that you might have, and connect and unplug or plug in the tools and take actions. So to conclude, I think OPEA provides a suite of microservices and examples of GenAI. I think it's already told. I will not again get into the details of that. OPEA follows open API standards. That's a very clear thing that you need to note. It follows OpenAI kind of REST API endpoints, so it's easy to integrate with your existing implementations. It is also optimized for a lot of the underlying hardware. So optimized strategies for open source LLMs, and it's all built enterprise grade. A lot of things are built enterprise grade, so you can use this as a starting point to build your own solutions. So call of actions, please check out all the agents microservices that are available. A lot of examples are there, and if you find any, please contribute, please get involved, and at any point in time if you need any help, please talk to us and we'll be more than happy to help you out.
Thanks, Anish. Thanks for
Thank
the
you, Sachin.
example. So what we're going to do is we are going to take a quick break. We are a little over time, 5 minutes, so that's not very much, but we will still love to have the entire schedule on track. So we'll take a small break, maybe 5 to 7 minutes, and let's get back. It's 10:49 currently. If we can get back at 10:55, we can start with the rest of the sessions. So let's take a quick break and come back again.
Thank you. Thanks, everyone.
All right, welcome back. We are going to start the second part of the session in our next couple of minutes. We will be covering three more important topics, as you can see on the screen. At end of it, we will have a quick call to action as well as questions and answers if you have missed anything. Like I said before, we are going to follow up with OPEA hands-on training coming up later in the year, and please check out your emails in case you are interested to attend those trainings. These trainings will be handled virtually, and then we'll be actually doing hands-on workshop on some of the use cases which were described today. So be in touch with our team and we will let you know. So with that, I'm going to invite the next set of speakers, Chris and William. Both of them are key senior solution architects for AI at Intel, and they're going to talk about OPEA solution as well as powered by OPEA and how to really track moving from OpenAI to open source with OPEA. So Chris and William, if you're ready, you can start sharing and start the session. And also I will invite Syed from my team to be my co-host in taking the second half ahead on the track. Okay, so Syed, over to you, and over to Chris and William.
Yep, sounds good. Can everybody hear me properly?
Yes, we can.
Okay, perfect. All right. And can everyone see my screen properly?
Yes, we can.
Okay, perfect. As we mentioned before, William and I will be presenting about deploying open platform for enterprise AI, also known as OPEA, to augment your existing solutions. And so before we deep dive into the details of this deployment, I want to first look at enterprise AI and GenAI from a broader perspective. And so today, enterprises have reached an AI inflection point, a pivotal moment in their AI adoption journey, as it is characterized by the swift adoption trends and the transformative impact of generative AI, which is reshaping industries and enterprises. In fact, by 2026, sorry, let me move this. 80% of enterprises are expected to leverage generative AI in their workloads, according to Gartner's 2023 research. And similarly, edge computing is becoming increasingly integrated with machine learning. By 2026, at least 50% of edge deployments will involve machine learning capabilities, enabling real-time decision-making closer to the data source. And so this growth is also reflected in enterprise investments. Spending on GenAI is forecasted to increase dramatically from 40 billion in 2024 to 151 billion by 2027. This data, sourced from an IDC survey, highlights the willingness to adopt AI and GenAI. However, enterprises are struggling to bring their AI workloads and solutions into production. Throughout our work at Intel, many of our customers have been challenged throughout the development and deployment of their GenAI solutions, whether it was the process of identifying the main components of a GenAI or RAG pipeline, questioning how they are stitched together or whether they are replaceable, whether they should be opened, closed, or how they would scale or validate their solutions. And so as we can see from this Gartner survey that investigates the main barriers that enterprises have in their adoption of AI, and if I were to highlight a few of the primary reasons, enterprises are struggling with the technical implementation, which reflects the complexity of deploying GenAI systems, from integrating models within existing infrastructure to scaling them for production. Then there is the cost of running GenAI initiatives that is driven by the high expenses of training and maintaining models, including cloud usage, specialized hardware, and skilled talent. And another major barrier relates to the governance and privacy, where there are concerns about data privacy and ethical issues such as bias and discrimination. And so additionally, from our interactions with our customers and partners, we have determined that these concerns are still very much prevalent within already existing GenAI workflows. On the technical implementation front, enterprises have, for example, been hindered by the complexity of integrating new capabilities, functionalities, frameworks within their existing solutions. And furthermore, enterprises have been finding it constraining being locked into close ecosystems and having to depend on only select proprietary technologies. And when it concerns costs, many enterprises are becoming increasingly aware of the costs associated to fine-tuning, training, and are starting to look at alternatives, such as using small language models versus LLMs, or using closed versus open ecosystems. And finally, of course, when it comes to privacy, enterprises are concerned about data privacy, transparency, bias, and fairness issues, especially when it comes to the black box of closed ecosystems, such as OpenAI. And so with all these barriers and concerns in mind, this is where OPEA fits in. So the Open Platform for Enterprise AI, also known as OPEA, is an open platform of composable building blocks for state-of-the-art generative AI systems. At its core, OPEA is about simplifying the development, production, and adoption of GenAI for enterprises. And by providing a modular system of components such as large language models, data stores, RAG, or even prompt engines, enterprises are no longer constrained within rigid frameworks. Instead, they can consume individual components or construct entire workflows from OPEA with remarkable ease. And whether enterprises are working in the cloud, on-premise, or at the edge, OPEA's deployment versatility and flexible architecture allows you to run your applications and workloads everywhere. And additionally, OPEA is committed to an open ecosystem. Traditionally, AI platforms often lock users into very specific vendor ecosystems or computational models. And OPEA allows you to overcome those limitations by providing a vendor-neutral toolkit that empowers organizations and enterprises to build precisely the AI solution that they need. And before we dive deeper into our particular customer use case, I just wanted to go over some of the initial customer context and some of the requirements that our customer had before we kicked off our initiative. And so our customer here that we've been working with is ISTE, ISTE plus AFCD, which is an educational nonprofit that helps educators use technology to transform teaching and empower learners. And Intel partners with ISTE at first to enhance their Stretch AI tool, which is a retrieval augmented generation-based chatbot that uses their private research knowledge base as added context. And before we started, they had a few requirements that they had in mind. And the very first concern was privacy. And given that they are an educational nonprofit that handles teacher and student information on the daily, they were quite apprehensive about their proprietary sources and sensitive data being trapped within the OpenAI ecosystem. And therefore, they wanted to look into alternative open source models and frameworks. They, of course, wanted their solution to perform similarly to their current chatbots in terms of answer quality of the outputs that they were currently getting from OpenAI. And additionally, they wanted a solution that would be easy to use and implement, given that they had spent a lot of time and effort building their current workflow. Given that they had spent so much time, they really did not want to spend additional time to stand up another application from the ground up. But rather, they wanted to augment specific portions of their workflow, like integrating open source LLM and frameworks and allowing their solutions to become more agile in the future, where as new models would come out in the future, they could easily swap them out for newer ones. And finally was the cost requirement. Overall, they wanted their service to have a predictable cost and lower TCO, as they envisioned their application to scale quite significantly moving forward. And so, as you can see here, this was their initial RAG LLM architecture diagram. Their solution, which is Stretch AI, which is a chatbot, uses a private knowledge base of their pre-processed sources that are chunked, vectorized using OpenAI's embedding service. And these are then stored into their Superbase vector database. Then when the query is received, this additional context that is stored in the vector database is then retrieved through a vector similarity search and combined with a prompt template to be sent to OpenAI's GPT-4. And so throughout this workflow, we identified two main areas where we were going to make some changes. So first we look at their embeddings process, which used OpenAI's embedding model 3, which we plan to replace with an OPEA text embedding inference endpoint, hosting an open source embedding model. And secondly, we looked at the final inference call, where instead of feeding the queries into OpenAI GPT-4, we wanted to augment that solution by creating a VLLM OPEA OpenVINO endpoint that made use of an open source large language model. And so the modifications that we made here are relatively simple. Instead of calling the OpenAI endpoints for the embedding and LLM inference processes, we simply set up OPEA endpoints, hosting the open source embeddings and large language models of our choice to replace them. And so what made this transition so smooth and seamless is the fact that the code changes needed to be made were very minimal. For the LLM endpoint, the OPEA VLLM instance that we stood up for them is actually chat completions compatible, meaning that we used a lot of the same code that they used before, making really minimal changes to their entire code base in order to make this migration. And so basically, it basically acted as a drop-in replacement for their particular solution. And for the embeddings endpoint, we kept all of the embedding and digestion function calls the same, and just had to replace the API calls to OpenAI to the self-hosted embeddings model with TEI. And taking a closer look at the changes that were made, first of all, was the inference call. Everything pretty much stayed the same. Their existing retrieval mechanism, the algorithm that they were using on the back end to compare the embedded question and the embeddings coming from their vector database stayed exactly the same. And so what we did instead of making the API call to GPT-4, instead of passing the contextualized prompt to OpenAI's model, we instead pointed it towards our OPEA endpoint, which was serving a base Llama 3.2 3 billion parameter model with the LLM, all of which was running on IST's own private infrastructure. And what I want to point out here is the ease and flexibility that is made available here. With OPEA's LLM microservice, you are given the option of what backend you want to use, whether it's TGI or VLLM, and the freedom of what open source model available you want to use from Hugging Face. And additionally, standing up the endpoint itself is quite seamless with OPEA's use of Docker images. Next is the embeddings. And IST already had implemented a whole embedding workflow where they embedded their HTML and PDF documentation they used to populate their vector database. And we changed none of these existing functions. We used the same data chunking methods, the same retrieval mechanism. And so again, we tried to reuse as much of their code as possible so that the changes that they would have to make would not have to be so extensive. And so they would not have to go through the lengthy process of recompiling or recreating everything from scratch. And in this case, we replaced the embeddings calls being made to OpenAI's text embedding model 3 with our OPEA embeddings endpoint, serving a BGE large 1.5 embedding model with TEI, again, hosted on their private infrastructure. And finally, we have the helper functions. Those were smaller functions that were in charge of creating conversation titles, summarization, and formatting. And they also use OpenAI's chat completions format. And therefore, we were able to keep all of their helper functions identical and simply swap out the API calls being made to OpenAI's GPT-4 and direct it to the OPEA endpoint that we had already set up for the inference function. And so here, we'll quickly go through some of the code changes that we have made throughout this migration. And so the inference using VLLM side of things, you can see that the chat completions is pretty much works the same way. The main difference here are that the OpenAI key will be empty since we're not using their service. The model that we're using will be an open source model of our choice, and the API base will be pointing to the VLLM server instead of just calling upon the OpenAI API call. But other than that, we are similarly just passing in the payload. We're similarly just like passing our payload, the client chat completions that create that the OpenAI API call uses. And so we are calling it the same way and returning the chat completions object the same way and extracting the text from it the same way that they were doing it with OpenAI previously. And on the embedding side of things, the changes were a bit different. Given that the text embeddings object that we would get from OpenAI was a bit different from the object created from the open source embeddings model that we were using, we had to slightly change the way we were processing the objects in question. So when we were using OpenAI, your object would go into a dictionary value to parse through the encoding vector. Whereas when you're using TEI, with the open source embeddings model, it actually is going to return an array that contains vectors within that object. And so it is a slightly different way of accessing it, but once you're able to retrieve the vector, you're able to use your existing RAG workflow to contextualize your prompts, and the retrieval mechanism will essentially stay the same. And yeah, so after being able to implement the changes that we have previously talked about, ISTE looked at scaling their application. And obviously, when you think about scaling, cost is probably the main blocker that comes to mind. But as you can see from this projected cost analysis that we carried out for ISTE's application, one of the large benefits of moving to a self-hosted infrastructure is that the cost will remain fixed and predictable as the solution scales. Given that RAG-based queries are often quite hefty, depending on your prompt template, you may see queries come close to 20,000 tokens in and about like 1,000 to 3,000 tokens out. And therefore, OpenAI's cost can spike as their pricing model revolves around input and output tokens per query, and per query and per request. And in the end, this cost predictability meant that ISTE, our customer, was able to test and innovate and add new features such as profiles without really thinking about the cost of scaling or testing that they would probably have to worry about using OpenAI. And to wrap it all up, overall, what did we learn from this particular experience? First is that when it comes to RAG or retrieval augmented generation, smaller models can match the output quality of larger, like 100 billion to trillion parameter models, especially when your particular workflow requires a lot of the information to come from the context of your vector database. And using a smaller model that understands the instructions better and takes advantage of relevant external context, rather than a model that is generating information only from what it has been trained on, can actually produce outputs of similar quality. That also means that you do not need the enormous amount of compute that you would normally need to run a much bigger model. Additionally, we learned that prompt engineering goes a long way. At first, the answers that we were getting from the out-of-the-box Llama 3.2 model were not at the required standard, but having prompt templates to kind of guide the instructional model that we were using exponentially increased the quality of our outputs. And in terms of optimized frameworks, given that ISTE's infrastructure consisted of Intel 4th Gen Xeon processors, we made sure to quantize the model to an int8 precision to be able to take advantage of the built-in acceleration instruction set called AMX. And thanks to that, we were still able to get a relatively similar output speed that you would get if you were doing API calls to OpenAI. Next, I would say that the most difficult part of this whole process was actually to re-embed the database. And so given that OpenAI's embed model 3 does their embedding to the size, to the vector size of 1536, and given that the new vector size being produced by the open source embedding model was 1024, we were not able to take advantage of RAG when it was first implemented into our solution. And therefore, we had to basically re-embed the corpus of data that they were using in their vector database using the new embeddings model to be able to match the 1024 vector size that was being used throughout the new workflow. And finally, with the help of OPEA, engineering changes can be done quite easily and quite fast. As we have explored throughout this particular use case, you can easily change the back end frameworks that you want to use. You can easily switch over from only using a CPU to using GPUs with the OPEA optimizations, or you can easily swap out your model to explore new open source models when they come out, which overall will allow your teams to focus on what is important, which is innovation. And yeah, I think that was it on our end. But thank you for your time, and thank you for this opportunity.
Hi, Chris. Thanks for your insightful session. And participants, attendees, if you have any queries, please do post it on chat. We have Chris and we have William as well, who will be able to respond to your queries. Right. And with that, let me quickly introduce myself. I am Syed and I manage developer marketing and engagements at Intel for APJ region. And I'll be kind of co-hosting this event for the rest of the event. Right. And with that, let me introduce our next session, which is GenAI Security and OPEA, presented by Dr. Sriram Vasudevan. Dr. Sriram, he is a lead technical evangelist at Intel and he has more than 17 years of experience with a great blend of industrial experience, R&D and teaching as well together. He has co-authored 47 books for reputed publishers across the globe, and he has authored 150 research papers in revered international journals as well. And he has 36 papers in international and national conference also together, and granted with 14 patents. He has PhD and he has done his master's in embedded systems. With that, let me welcome Dr. Sriram and take it up. Thank you, Sriram.
Thanks, Syed. Good morning, everybody. Good evening. Please make me co-host, Syed, if you can.
Sure, Sriram, we'll do that. Yeah.
You can share your screen.
Yeah, done, Sachin. Yeah. I hope you are able to see the screen. Could you please confirm, Syed?
Coming up, Sriram. Yeah, we can see now.
Perfect. So once again, good morning, good afternoon, good evening, and thank you very much for joining us today. We had a lot of wonderful sessions and they were all very quick and they explained you what OPEA is all about. The mission of OPEA is to create an open platform that enables creation of open, multi-provider, robust, and composable GenAI solutions that harness the best innovation across the ecosystem. So I hope you would have clearly understood that. And we are going to talk about a very different thing, which is very important actually. That is the security perspective with OPEA. What OPEA offers you and how it is going to be really beneficial. That's what we are going to discuss. We will start with the mission. Everybody discussed that, and we are not going to touch more on that. And OPEA offerings, the security perspective, what does OPEA offer you will be discussed. Followed by that, we will touch upon the triads which are really to be handled nicely and how OPEA handles it. Then we will talk about the prompt injection mitigation, guardrails, and by then it will be 20 minutes for sure. And we can take up the questions if you have any. All right, so let's get into the basic mission behind this OPEA security working group. We aim at setting up and bringing up a very strong security first mindset. The community, whatever we are here for, should prevent and respond to security issues very nicely. Mostly what happens is after only a particular problem is reported, after something has happened, we prioritize it and then we kind of go ahead and sort it out. It will become very expensive at that time and it's something that we should not do. But we need to really get the solutions available. We need to be proactive. We need to make sure that we have got complete idea about what it is even before the problems occur. So that's what OPEA Security Working Group is aiming at. The Security Working Group will adapt the best practices from all established security organizations who are giants already in this area, and we try to educate the community. Most importantly, security is always not one man or one organization's responsibility. We all would definitely agree to the fact that security is a collective responsibility. We all have to do something. We all have to do our bit to bring security, and it's everyone's responsibility. So the working group members here are very clear in kind of bringing up this responsibility to everybody. And we are also acting as security matter experts to help review pull requests and most importantly, to secure the design and implementation. So this is the overall agenda that we have with respect to the OPEA's security group. And the current scenario is very, very interesting. The generative AI solutions, as you and I know, they definitely provide significant gains for the businesses. We all want to embrace it. We want to utilize this advantage. We definitely want to make profits out of it. But one perspective is really very difficult, and it's challenge actually for all the enterprises. The enterprises are not really 100% ready, and it's not easy for them as well in terms of security, features, consistent performance, scalability, and resiliency. All these have to be also in place. They are to be in place while we are looking at significant gains for the businesses through GenAI adoption. So this is a definite challenge that we have in our plate. And OPEA provides you a great sort of support to all these. Multiple security related features, and they all will definitely ensure that the generative AI workflows in the enterprise environments are going to be safe. OPEA also very clearly governs and provides you community norms, workflows. The releases which are going to be issued will be perfect. And most importantly, the policies and the security issue reporting methods and the policies are also very clear. OPEA also goes ahead and it embodies the cloud native security best practices. And that way, we can securely definitely harness the internal and the external data sets. And above all these, OPEA is all about getting it enterprise ready. We are going to get a very secure enterprise ready pipeline, and the tools which come up with us are going to ensure responsibility, transparency, and traceability. They are very important these days, and we cannot compromise on that. OPEA provides us all these. And above all these, the four-step assessment that OPEA suggests for grading generative AI systems is really phenomenal. We're looking into the performance, the features, trustworthiness, and the enterprise grade readiness. This four-step assessment is going to ensure that whatever we produce with OPEA, whatever we build with OPEA is going to meet the expectations. Also on the other side, the security, resiliency, and observability is also considered. OPEA definitely keeps an eye on enterprise level concerns. These are all very strong concerns that enterprises have. And we actually go ahead with providing strong solutions, strong support for building the solutions with security, resiliency, and observability. Not only efficient your system should be, but also it should be secure and it should be reliable within the complex ecosystems. OPEA goes ahead and OPEA ensures this. And microservices are the most important advantage that OPEA gives you. Many composable microservices which are available for you. We have listed a few in front of you. The most important advantage, they are all modular. And this modularity is the biggest gift we have in hand. This helps you maintain the security. Only the necessary components need to be deployed, and this way we can reduce the attack surface. We will talk about it a little later in a little more depth. And please understand, these microservices are super gift. We have got composable microservices, a suite of composable microservices are there, and they are going to help us in building generative AI solutions without any compromise. So they are enterprise grade as well. I recommend you to go ahead and have a look at what are the kind of microservices that we have with OPEA. Well, it's time for us to look into the triads. We have got three very important things, and we need to understand what is the impact does it bring in the GenAI and how OPEA helps us to overcome that. The first one is the attack surface. The second one is independent security management. Third one, as we understand, is scalability and resilience. How do we get it? Very simple. We will start with the attack surface and what's the impact that it brings on GenAI. What is it? Very simple. It is always about the potential entry points that malicious actor can exploit in the system. I'm going to talk about the potential entry points, where all the malicious actors can enter. Where all it could be. Normally, it would be the open ports, the APIs, the user interface, third-party integrations. All these are the potential places where someone can enter. A large attack surface always increases the risk. So thereby, what will happen? The AI models will become more vulnerable. It will open doors for data poisoning, prompt injections, whatnot. Many other attacks can also come in. GenAI systems are often connected and married to APIs. We cannot avoid APIs, and we all know that. Cloud services are, on the other hand, they are very closely connected. We have got real-time data streams coming in. So one exposed attack surface can lead to unauthorized data access or model manipulation, which can spread across in different aspects, and that is going to be super dangerous for us. This is to be definitely avoided. So how OPEA helps here? The first point that we need to understand here is OPEA allows the enterprises to deploy only the necessary microservices. That way, we will minimize the vulnerabilities. And very important aspect that we need to understand is, since each GenAI component, for instance, take data pre-processing, model inference, or storage, all these, they are all isolated. The attack surface is kept minimal. So first one, reduced attack surface. Second one, the attack surface is kept minimal. That way, OPEA is going to help us out. The next important aspect we need to understand and investigate is the independent security management and what's the impact that it brings on GenAI. Each microservice runs independently, meaning that the security policies, the patches, and the access controls can be applied at the microservice level without affecting the other parts of the system. The traditional monolithic AI systems may suffer. I repeat, the traditional monolithic AI systems may suffer security breaches that affect the entire system, leading to complete model runtime. Independent security per microservice ensures that the vulnerabilities in one service doesn't affect, or it will never compromise, the entire AI pipeline. That way, we are going to be super safe, and it's going to be good for us. Now, how OPEA is going to help us out? First one, microservices isolation. We spoke about it. The second one, targeted security updates. Right. Let's go a little deeper into microservices isolation. If a vulnerability is detected in one GenAI function, for example, a model inference engine, OPI ensures that it can be patched separately without bringing down the entire system. That's the biggest advantage. Second, the targeted security updates. The enterprises using GenAI do not need to halt operations for security fixes, making deployments more agile and more secure. So that way, we handle this part as well. The third one is going to be super important. Scalability, resilience, and their impact on GenAI. What is scalability? We all know it's the ability of the system to handle increased workloads efficiently without compromise, either by adding more resources, we call it vertical scaling, or by distributing tasks, we call it horizontal scaling. Second very important term here is resilience. It's the skill, ability, capability of the system to recover from the failures while maintaining the operational efficiency. Please understand, all the large-scale LLM inference tasks that we are working on definitely demands flexible scaling, right? Particularly when real-time user interactions and real-time stuff are engaged here, it's going to be definitely flexible. And on the other side, the GenAI solutions are pretty much prone to heavy compute loads. A failure in one module, take any part of it, should not impact the overall AI generation workflow. So we need to be very careful about it. So how OPEA is going to help us out here? OPEA is going to get you scalable microservices, and it's also offering us resilient AI workflows. OPEA ensures that each GenAI module, take any module for an instance, text generation, embeddings, image synthesis, it scales independently. Therefore, it prevents the performance bottlenecks. On the other part of it, resilient AI workflows is very important. If one microservice fails, other GenAI services will continue functioning without any havoc. It's going to not affect anything else. Therefore, the downtime will be prevented. These three are very nicely handled by OPEA. The triads are pretty much handled. Now comes the prompt injection. What is prompt injection? We all know it. Malicious actors can come ahead. They will manipulate AI model by crafting, by creating deceptive or any adversarial prompt inputs. Attackers can alter the AI responses. They can do anything like leaking the sensitive information, harmful output, anything can be done. So this way it's going to be a problem and we got to mitigate it. How do we go ahead with it? OPEA helps even here. OPEA has got solution for everything. A recent contribution that has come up from Prediction Guard, we will give you the link and we recommend you to strongly go ahead and have a look at it. This recent contribution from Prediction Guard addresses the prompt injection attacks very clearly, and the toxicity in the AI output can be mitigated. This is very crucial for preventing malicious actors from manipulating the AI models through specially crafted inputs, particularly in the era of explainability, era of explainable AI becoming very, very important, and security with respect to AI becoming very important. These kind of support with OPEA is going to be really useful. The next thing is going to be very interesting. The cloud native security best practices. Yes, we have to see this for a minute. OPEA is specially designed with cloud first mindset. Therefore, we ensure that all the micro components and sample GenAI pipelines are cloud native. They are containerized. They are deployable in Docker and Kubernetes environment. It's going to be very easy. Therefore, we get the secure deployment on premises or in cloud service providers, whichever we prefer. This way, we can adhere to the cloud native security best practices. Therefore, we get the best of the security enabled. And the next one is going to be very important because of this approach that we follow. We get cloud native security emphasized and we safeguard all the AI models and the data. We also can ensure the data privacy, which is paramount. We also prevent the security risks, vulnerabilities, prompt injection kind of attacks, data breaches, everything can be minimized. And next comes the very important thing, guardrails. Yes, OPEA has it. As I mentioned it rightly, the guardrail GOTS. It ensures the output quality. Yes, we have got guardrails which are going to ensure that all the generated content follows predefined standards and formats. And importantly, consistency, uniformity in the responses shall also be maintained. Reliability, of course, yes, we cannot compromise that. The trust factor with respect to the reliability is also ensured with the support of guardrails. And comes risk mitigation. We also, with the support of guardrails, detect and we can prevent the risk well in advance. The hallucinations are something that we have been frequently discussing with the AI models, and the toxic language, the data leakage, all these are handled well. And misuse, we can avoid the misuse of the AI engines with the guardrail support. Trustworthiness, as expected, it's also improved with the support of guardrails. And compliance. Yes, we have to go ahead with compliance of the norms. Most importantly, guardrails help you in ensuring compliance and enforcing guidelines. It applies restrictions very clearly within the complete AI workflow to maintain the security and to adhere to the ethical standards without compromise. We also have the enterprise level deployment clearly supported. We can have the compliance requirements clearly met even when you go for large scale adoption with the support that is provided from OPEA. Please remember, you can contribute. As the speakers who have been repeatedly telling you, it is not a single person's movement, it is collective. You can join the security working group as well. Please scan the QR code and you will be able to get a lot of information. You can contribute, you can be part of it, and we welcome you to be involved in OPEA. The key takeaways quickly before I conclude, it helps to integrate the performant GenAI workflows and applications across enterprises and across enterprise systems and networks, all securely and safely. It's always practical and easy to build the GenAI RAG applications with OPEA, the Mega and the microservices on the Intel Gaudi and Intel Xeon. You will find the best results there. Using OPEA is the best, cost-effective, and you can use it to scale and deploy AI solutions. You can have all the resources by referring this link. It is all available in the github.com/OPEA-project. We've got a lot of materials there. You can learn, you can reach to us as well. We'll be very happy to assist you. And quickly I display the notices. With that note, I would like to conclude my session and we'll be very happy to take questions if you have any. Right, over to you.
Yeah. Thanks, Sriram. Thanks a lot for that excellent and engaging session. So probably we'll just wait for a few queries on the chat and then we'll take it up.
Sure.
So Syed, why don't you take the queries offline and
Sure.
a little later of the next session?
Yeah,
Yes.
we have
Yeah, we'll
queries.
do that. Yeah. So we have a very interesting session next called OPEA on Azure. So which will be represented by Kaushal Desai from Infosys. So Kaushal is distinguished AI technologist at Infosys, and he designs and implements AI solutions using cutting-edge LLM ops solutions for various customers. Deep expertise in AI and LLMs, deploying models at scale, quantitation, inferences, model pipelines, and model fine-tuning techniques. He also leads the AI platform and LLM ops teams at Infosys. His team focuses on scaling AI and bringing efficiency by using the latest AI technologies in model inferencing and training across different hardware platforms for Infosys as well as for their customers as well. With that, let me welcome our speaker, Kaushal Desai. Over to you, Kaushal.
Thanks, Ed. Thanks for warm introduction, and I hope wherever you guys are, you're having a nice day and session so far. So with that, I just said quick confirmation. I'm assuming that I'm audible and my screen is also visible.
It's clear, Kaushal. Both are clear.
Lovely. So here is the thing, right? So we at Infosys are in a unique position when it comes to open source projects. So one of the key things we started adopting AI in terms of in our own processes and technologies internally before we go and work with our 500 odd customers around the world on various aspects of AI, etc. So a lot of our internal processes, for example, applications that assist employees, HR policies, and there are tons and tons of other applications that comes as a part of project management and account management and stuff like that, right? I mean, I don't even know the list of applications that today we support. Where we are trying to figure out what are the AI first experiences. Some of the things that we are doing internally is to adopt an AI based assistant for every persona of Infosys. So for example, a lot of sales guys and pre-sales teams who work on a lot of customer RFP, RFIs, etc. So we try and can a lot of our RFP, RFI documents into a common repo and build a RAG on top of it. There are applications where we have about 350,000 employees around 70 plus countries looking for all kind of information through our policy, HR policies, etc. So we are creating, we have deployed a system which can basically help them. We're also using tooling, like for example, if you are in a so-and-so country, deputed, what sort of leaves you have, what is your current leave balance, what is the leave balance in your home country, all those things integrating with our internal systems, which does leave management, salary related, compensation related, claim related. So there are lots and lots of assistance that we are building as a part of it. And all of these things we are doing internally in-house Infosys. So we are foremost, we are the consumer of the technology as well as we are the provider of the technology to our customers, right? So the way we are using in Infosys is very simple. We have our own set of platforms, which are mobile, desktop based applications that can be accessible. Some of these applications comes as a part of your Microsoft Word custom applications, Microsoft PowerPoint custom applications, etc., where we are able to use some of the multi-models also to find specific images, etc. And the whole setup, the way it is done is we have an API gateway for an internal and an external facing users because we have people, we don't expect people, all of them to log into our network. So we have our own private cloud instance, which comes via API gateway. All of these services are built on an Istio-based Kubernetes cluster, where some of these OPEA services we are deploying in terms of retrieval, augmented, re-ranker, and generational services. On top of it, we have our own guardrails. So in the earlier session, what we are talking about that you have set of microservices in OPEA, which you can pick and choose. So this is something that is available for our customer. We have recently open sourced this responsible AI toolkit, which is basically a combination of various guardrails put together in a nice way where people can access those things, etc. And we have an on-premise GPU compute, as well as some of our services have to be deployed in cloud because of the need, just proximity to the where our data is, some of our data is, right? So that's a reason where we have some of those things. And then on top of it, we have different kind of models that we use. So one of the models we rely heavily on Llama and Llama based models, as well as some of the open source models that we have fine tuned for our needs, like embedding model, generative models, even re-rankers. We are in a process to fine tune on some of the aspects. And the second part is some of our application data, which is not very sensitive, etc. We are still using Geminis and those sort of closed source models. So that is another AI gateway that exists on the premise, which goes via that, right? So as an organization, we're quite complex in terms of how people are needing to deploy these services separately, and that's where OPEA comes into picture, right? That it can support different type of models. Like I said, we are like, for example, a lot of services can be deployed on either Intel CPUs or Gaudis or even NVIDIA GPUs. Some of our models, larger models, are on GPUs, and some of the smaller models like embedding model, etc. We have some of those things also putting on Xeon CPUs, right? The Gen 5 and above CPUs, right? One of the key things when we were deploying, what we realized is we wanted to use Elasticsearch because we have a private Elasticsearch instance on premise that's quite large, which we use for our other search services. So we wanted to use those content, etc. OPEA being open source, we said, hey, why can't we adopt OPEA? And at the same time, let's extend OPEA to include the Elasticsearch related components. So anybody in the community would want to use Elasticsearch as a vector DB can use that, right? So one of the fundamental thing why we went about choosing Elasticsearch, right? And this question comes up quite often with a lot of our conversations. One of the key things is Elastic is one of the very early databases that supports hybrid search, right? Now that we are in the journey for almost a year, we can tell you that it works at volume. Secondly, we have done multiple experiments. As you can see, this graph is slightly smaller, but if you look at it, we have created different models, used different models, embedding models, just to check the retrieval accuracy with dense re-ranker, standard drag, as well as hybrid with RRF sort of a matrix, right? And every single time for our data set, our queries, this leaderboard and benchmark has worked better for hybrid search, right? So Elastic provides the sparse and dense search out of the box. That was one of the key choices early on. Now I wish that they support flag embedding sort of embeddings, also hybrid embeddings, etc., so that we can use something like Vespa. But nonetheless, we are stuck with the choice, and it's doing pretty good. So there is no reason for change. Other things are all the security bits, etc. We are quite comfortable in Elastic because we, although we are a big company of 350,000 people, not everyone would want to have access to all kind of content. So there are different levels of security on the content, like some of the proposals, commercial information, etc. Those accesses are only given to certain users, certain LOBs. So we are able to do ACLs, etc., doc level securities, all those things we are able to embed. Plus, we also have our own graph structure, which kind of we are using along with Elastic to make sure that we are able to secure our content, make our queries a little better, etc. Some of the things you might have noticed that Elastic now supports AVX instructions. So technically, if you deploy Elastic on, let's say, Xeon-based servers, which is your NUMA architectures, etc., which by default now supports AVX, the benchmarks are much faster. And some of these design choices enabled us that, hey, let's have put those support in, and some of the code we have open sourced it in form of a PR. Later part of this presentation, I'll walk you through some of the PRs that we have submitted and doing things, right? So this is one part where how we are consuming, what we are contributing to. So this is a use case where Infosys is a consumer of OPEA as well as contributed to OPEA, right? And being open source, being microservice, I or my team doesn't have to go into every single little microservices. All you need to do is to understand the orchestrator service properly, look at retriever, data prep, some of those core components, make changes according to your needs, and customize some of the search part where you might want to do things like query generation or query rewriting or self-reflect kind of patterns if you want to put it as a part of your RAG architecture, etc. So that kind of works really well for us. Plus, it is native it's a cloud native. So as long as you have a good Kubernetes cluster available or you are able to deploy a container anywhere, it works like a charm. So that means I can use same set of services, component code on premise, on cloud, on different infrastructure, whether it's GPU, CPU, etc. The build system that the way OPEA has put in, right? That how do you want to build it, whether you want to build it on VLLM, whether you want to build it on TGI, different serving infrastructures, etc. All those things are quite flexible. And that kind of works, it elevates a lot of concerns that developers have as of today, right? So this is one part as how we are putting this out there. Second part is when we talk to our customers, right? They really want to do a lot of things on cloud native. So one of the things that comes across when we talk to customers is either Azure, strong preferences or on either Azure or AWS based on where their sensibility lies, etc., and the work that they've done, right? So key thing that we realized when we started doing this for our customer is their fundamental choice for vector search is Cosmos DB, right? Cosmos DB, like Elastic, provides all kind of hybrid search related function. It's quite scalable. We all know the advantages of some of those services, etc., right? So we started putting changes related to Cosmos DB. So there is another PR that is already merged, etc., which basically allows you to set up entire OPEA on Azure, where as you can see that it will spin up a cluster. It will start with basic traffic ingress controllers, etc. We are not putting our own service map here. We have kept it OPEA native. And this whole thing is available as a part of Azure Marketplace listed. You can go, source code is available in Azure repo at Node. And even the marketplace listing, etc., is not cost driven. So technically, you can just copy the whole things, deploy the things in a minute time. If you have a cluster, if you don't have a cluster, it will create a cluster. It will have a few things in terms of how the cluster can scale, 1 node to 10 nodes, etc. Plus, it is natively integrated with Azure in terms of using Azure file services for storing the models or some of the logs, data, etc. All the logs, telemetries are pushed via are done using OTel. So technically, OpenTelemetry is supported on Azure Monitor, so you can push out telemetries and monitoring, etc., to Azure, and use Cosmos DB as a vector DB, right? And the services related to data prep, retriever, etc., works out of the box, right? So that's kind of thing. What I'll do is I'll quickly just show you some of the repos that we have here. So if you go into GenAI comms, there are multiple components as would have been already explained, GenAI infra, comms, etc. Within infra, if you see there is this Azure AKS. So within cloud service providers, there would be Azure and AWS are two cloud providers as of now supported. Azure is something that we did here. So there are all Terraform scripting, variables, provide your Cosmos DB accounts, what are your PVCs, etc. So technically run your Terraform scripts, get your cluster up and running. Here, sample chat Q&A application is also provided as a part of deployment. So once you do that, it's up, your OPI is up and running. Obviously, there are cleanup scripts, etc. Those are available with documentation. So feel free to play around with those. Some of the other components, if you want to look at it, some of these PRs that I mentioned we'll talk about. You can go and look at this PR and see what are the changes made, etc. So in case if you want to support your own vector stores, etc., it is available here. How do you support it? Or you can go into GenAI comps and look at some of those things as well, right? So all in all, our key learnings from this is OPEA being cloud native, it works in all ways in our favor, because what we develop within our own premise, we are able to offer that as an IP to some of our customers. From a customer point of view, the deployment, the development, etc., is really expedited. So really, you can have simple rags up and running within under a month's time if all resources, everything is available. Containers, everything is available publicly, so there is no need for me to work on IP related issue with customers, etc. They can straight away take the code, scan it, check for vulnerability, and move to as quick as possible to production and all. So some of the key things we also do is a lot of data prep services. There are a lot of new innovation coming up where multi-models are being used for a lot of complex documents, etc. So we have written our own data prep service as well. That is where we bring in Infosys IP and Infosys understanding of how we can utilize some of the enterprise specific complicated documents, etc., and enable the retrieval search better and straight away, can offer accuracies and overall leaderboards as well. So yeah, one of the least talk about services in OPEA is about the leaderboards, or as we call benchmarks. So most of the customers get it wrong, where they come up with 1,000 documents, do the search, and then once they put things in production, they have no clue what they are expecting, right? So we always a lot of our customers, when we work with, we start using some of the benchmarking related services that supports ragas and other things out of the box. So you can set up a leaderboard for the enterprises for their data, no matter what models you are using, whether it's OpenAI or open source. You can use that to tell your customers that what works, what kind of use cases will work, what kind of things would require. It's also a good feedback mechanism for a lot of developers. Some of the things that we do in production for Infosys today is also to capture the live feedback, and we use some of the telemetry or feedback microservices that are available. We have obviously extended those for our needs, but the idea is the architecture is there, components are there. You can change the way you want to and deploy it and adopt it the way you want to, right? That's the power of open source architecture as well as code that is at your doorstep. So I suggest, and my humble request is to get the code running on your laptops or on your systems or your Kubernetes clusters. Doesn't require much. It supports all kind of hardwares that you may be working with, and contribute more to the ecosystem so that everybody benefits from these projects. Right. With that, I'll take a pause and we'll take up any questions if we may have.
Thanks, Kaushal, for the informative session. Right. And people, if you have any queries, please do post it in the chat, and Kaushal will be here to help you address those queries. Right. With that, as we move towards the end of the session, I would like to invite back Malini to give us information about OPEA community and for the final closing remarks as well. Over to you, Malini. Malini, you're there? We can't hear you.
No worries. I think Malini is probably late in the US time zone. So what we'll do is we can do a quick wrap up. So as you must have seen the details on OPEA, and I hope that the entire sessions were useful for you to really start understanding a bit more about OPEA and start learning the nuances of it. We encourage all of you to connect to the opea.dev site, where, as you can see, there are tons of documentation, tons of examples available for you to try it out, have a first first sample, as well as the first learning at the OPEA website. So do connect with that, and then as the things evolve, you may like to try experimenting with some of these microservices, try out few use cases, and you can always connect back to Intel team to help us with what we can do with you. As Shriram mentioned, most of these are cloud native services can be worked on Intel Xeon and Gaudi accelerators. We can provide you a environment where you can try out these examples in a developed cloud environment. So let us know if you are looking at that. We are also doing a follow-up workshop series, as I mentioned before, on OPEA in the next few months. So we will share more details on that, and feel free to connect with us. As we are celebrating the first year of OPEA, we also wanted to have more contribution coming from the India developers, and the rich ecosystem for India definitely needs to contribute more to the OPEA as use cases evolve, and specific projects contributions. We definitely encourage all of you to kind of work together and then submit those contributions back to the OPEA project. So with that, again, many thanks to our co-presenters today who had spent their time with us, and all of you who had taken time out to attend the wonderful sessions around OPEA. Hopefully we'll connect back again and then continue this discussion forward, and hope to see you more projects coming in from OPEA. So till that time, see you again. Thanks a lot, and then have a good day. Thank you very much. All right.